All right, today we're going to try to finish up chapter one. I'm going to talk about equations of lines, what solutions are, solutions to equations of lines, and then linear inequalities. What is an equation? What makes an equation? Yeah, has an equal sign. That's an example of an equation. That's an example of an equation. That's an example of an equation. So anything that has an equal sign is an equation. Grab a sheet also. So linear equations have two variables. An x variable, which we call the independent variable, and the y variable, which we call the dependent variable. Why is x called the independent and y called a dependent variable? What does independent mean? Also, it could be anything it wants to. So if I have an equation, usually we have y by itself and x in the function. Can you tell me what y equals? Give me a value of y. You can't until you do what first? You have to pick an x, plug it in there, work it out, then it gives you a value for y. So you can pick anything you want to for x. Independent. It's independent. You can pick whatever you want to. Once you find that, the value of y is dependent on whatever x value you put in there. That's where it gets its name. So, for example, if x equals 0, I pick that. So it's 3 times 0 equals y equals 2. So now the value y equals 2 is dependent on x equals 0. That we have to remember what they're called because the x-axis is always representing the independent variable. And the y-axis is always the dependent variable. If you're a business and you're looking at your profits, what usually goes on the x-axis? Okay, let's look at something else. Let's say you're a coach and you notice that the more time you spend practicing, you win more games. So what would go on the x-axis? Out of that example, the more time you spend practicing, the more games you win. X-axis is always time. So the function is number of practice hours. Grab a sheet. So whenever you have any type of function and you deal with time, time is always the x-axis. And whatever you're looking for is on the y-axis. Finding an equation to a line. Now we're getting into some specifics. To find an equation of a line, we need one point and the slope. That's the minimum information you can have to tell me the equation of a line. So remember this. So let's look at, there are three forms of lines. I'll start from this formula. Remember, we need to have 1 point and a slope. So if I give you 2 points, you can find the slope easy. But if I only give you 1 point, 1 slope, what do we do from there? Let's see. So we have y2 minus y1 equals x2 minus x1 equals m. Today's class, we're going to look at a lot of examples with fractions as well. There's a basic rule. Whenever you have fractions in an equal sign, get rid of the fractions. Whenever you have fractions and an equal sign, get rid of the fractions. This is going to be our mantra for whenever we deal equations. Case in point, the slope formula. The slope formula is a fraction. How do we get rid of a fraction? Is that? No, that's a fine. How do we get rid of the fraction? Because how would we get rid of, on this side, how do we get rid of the x2 minus x1? Let's make it a little easier. What if I had 4 over 3? How would I get rid of the fraction, the bottom part? Now, what kind of equation is this? It's a division, right? What's opposite of division? So to get rid of the 3, we would have to multiply by, if we multiply by 3, that cancels. So then we have 4 equals 3m. So whenever you have fractions, you want to get rid of the bottom number, just multiply by it. Across the board, both sides. So what we have to do here, we have to multiply both sides by the fraction, or by the denominator, I mean. That gets rid of this. So we're left with y2 minus y1 equals m. x2 minus x1. So far, so good? Remember, we always start off with a point and a slope. Our point is x1, y1. Our slope is m. So these are numbers that have to be given to you to do anything. So what does that mean y2 and x2 are? Those are the rest of the x's and y's. The only point we start off with is x1, y1. And then from there, we follow the slope to the next one, then the next one. So we don't need these numbers y2, x2. So we just have y minus y1 equals x minus x1. This is our first formula. Can you guess what it's called? Let me give you a hint. Mathematicians are not too inventive, not too creative. It has a point and a slope. So what do you think they call this formula? Point slope. This is called the point slope form. You have to know the names of these things because in a question, you'll be given some information. It'll say find the equation of the line in point slope form or in one of the other forms. So you have to be able to connect that name with that equation. Or all you would do. So let's start with that. Let's start with the point slope form. Let's pretend our point we have is 3, 5, and our slope is 2. Plug it into the equation. Because remember, in order to find the equation of a line, you have to have one point and you have to have the slope to find the equation of a line. And we have those. So what's my formula going to be in point slope form? Where do I put these numbers? Where do I put 3? Which x? Which x? No. Well, that was a safe answer because it's x1. Yeah. You put this is x1 and this is y1. That's a safe answer. You meant this one? But no, it's this actually put them into. And this is your slope. So what you have here is y minus 5 equals 2x minus 3. There's your formula in point slope form. That's an equation of a line. Pretty easy. Just plug and play. Now solve for y. What do you have to do first? Before that. What order of operations? What do you have to get rid of? Yes. Always get rid of parentheses first. So to get rid of the parentheses, I have to distribute. 2 times x is 2x. Positive times negative is negative. 2 times 3 is 6. Well, what you normally do after you get rid of the parentheses, you combine like terms and then get y alone. There's no simplifying, there's no combining like terms, so we have to get y by itself. How do we get y by itself? We have to get rid of. Yeah, so now we do the plus 5 to both sides. Negative 6, positive 5. 6 is bigger, so it's minus. 6 minus 5 is 1. And there we have it. There's our second form. Whatever is in front of your x is slope. Sure enough, that's what it is. So this is your slope. And b is your what? What intercept? It's an intercept. But which intercept? X or y? Y. Because how do you find the y-intercept? If we set x equal to 0, equals y. So this is our y-intercept. That's our second form of the equation. This one is called, surprise, slope-intercept form. This is typically the equation that most people refer to when they say equation of line. Y equals mx plus b. Notice that the y-intercept, it's a location, it's a point. It's where the line crosses the y-axis. So what is the y-intercept? What is the value for b in this case is what, in this example? This is the y, this is the x. Yeah, so y equals 3. I mean, that's the y-intercept. So that's what our b value is. But what is the location of the y-intercept? Very good. The location is 0, 3. So you'll be asked that question on the homework. So it'll say, find the y-intercept. Or what is the location of the y-intercept? You have to look what specifically what it's asking for. Again, remember, all these came from the slope equation. The third equation. Now, place x and y on the same side. So we have 2x minus 1. So what we're going to do here is we're going to subtract 2x from both sides. Because we want x and y to be on the same side. The only stipulation is once you get X and Y on the same side, the coefficient of X must be greater than 0. That's it's called A. The coefficient of X is called A. So how do we fix that? This coefficient is negative. So how do we make it into positive? It has to be positive. Just change the signs across the board. Change this one from negative to positive. Change this one from positive to negative. And change this one from negative to positive. And here we have our third form. This is the third form. But the only stipulation is A has to be positive. This is called the standard form. The first week of class, I told you all that definitions are very important. You have to know what the words mean, because if I ask you to give me a specific form, you have to know what equation matches that form. Are we okay? Let's find the equations of lines. Example 1. Find the equation of the line going through -3, 4, and has a slope of 2, -2. I want to get you guys away from being afraid of negatives and fractions. Okay, you guys are starting to solve. I didn't tell you what form I wanted in, did I? In point slope form. And be in standard form. I know you guys are on the right path. Let me just get this so we can move on also. All right, so we have a point and we have a slope. The first one says point slope form. What does that one look like? What's the formula for the point slope form? That's the point slope form. Where this is x1, that's y1, and that's m. y1 is 4. M is -2. And x1 is -3. Whenever you put a negative number inside an equation, put in parentheses. Because the biggest mistake students do is they just put a 3 behind here because there's a minus sign already there. No, that minus sign is supposed to be there from the equation. I need x to be -3. And this is the only thing you have to change. Negative times negative becomes a positive. And there's your first answer. That's the point slope form. Now we'll take this equation and put it in standard form. Standard form looks like this, where x and y are on the same side. So I take this equation and I got to move x and y to the same side. So I have to get rid of the parentheses first. Negative times positive is negative. 2 times x. Negative times positive is negative. 2 times 3 is 6. Move all the x and y's to one side. Everything else goes to the other side. So we have to add 2x to both sides. So 2x plus y minus 4. Those cancel. We have to get rid of the minus 4. So we add 4 to both sides. Because we only want x and y on that side. Six is bigger than 4, so it's negative. 6 minus 4 is 2. And there's my answer. Why am I done there? Why am I finished? Why don't I have to change anything else? Because A, the leading coefficient has to be positive. Is the 2 positive? Whatever's in front of the x. Is it a positive number? Yes. I'm done. If it was a negative, I have to change all the signs. But since whatever's in front of x is positive, I'm done. Example 2. Find the slope-intercept form of a line given -3, 4 and 5, -3. So what's the first thing y'all did here? The first thing you should do is, what is the answer supposed to look like? What is the slope-intercept form? That's what we need. There's the slope, there's the intercept. Do we have either of those? No. All we have is 2 points. Can we find either of those with 2 points? What? How? How do we find the slope? What's the formula for slope? So we first have to find the slope. Okay, so given 2 points, find m equals y2 minus y1, x2 minus x1. That's the first step. So in our equation, y2, this is x1, y1, x2, y2. So we have -3 minus 4, 5 minus -3. -3 minus 4, they're both negative. 3 plus 4 is 7. If they're both signs are the same, keep the sign, add the numbers. Negative and negative becomes a positive, so 5 plus 3 is 8. So there's my slope. But I need to have, remember, you need to have a point and a slope. So we found the slope. Then second is choose either point. It doesn't matter which one you pick. Since this is already defined as x1, y1, let's go ahead and use that. This is going to be your x1, y1 point. Plug into the point slope formula. So my slope is -7/8. The point I'm using is -3, 4. Plug that in there. All right, this is my x1, y1. Y1 is 4. M is -7/8. And X is -3. Negative and negative becomes a positive. Remember, we always have to follow the order of operations. Order of operations says do inside the parentheses first. Only thing we can do there is multiply 2 negatives. So now we have y minus 4 equals -7/8 x plus 3. Step 4. But remember, we want it to be y equals mx plus b, so we have to solve for y. But we have a fraction. When dealing with fractions, and an equal sign, here are your steps. First step. Find the least common denominator. The LCD, the least common denominator. What is the least common denominator? What is it defined as? Least common denominator. Least means the smallest, common, the same denominator. So what's the smallest denominator that all the bottom numbers are the same? Well, there's only one denominator. So the LCD here is 8. Once you find the LCD, multiply each term by the LCD. How many terms do I have in my equation? Very good. Here's 1, here's 2, and here's 3. A term is anything separated by a plus, minus, or equals. Since that's inside parentheses, this all counts as one term. It's all multiplied together. So basically, all we do now is put an 8 in front of each term. The LCD times y, the LCD times 4, the LCD times -7/8 x plus 3. That's what we just did. We multiplied each term by the LCD. Step 3. Reduce. Because the whole purpose here is we want to get rid of the fraction. Before you multiply anything, always reduce fractions first. There's no denominator there. No. This 8 and this 8 cancel. There's nothing in front. We just have -7 x plus 3. These two equations are exactly the same. Which one looks easier to do now? The bottom one. Once you get rid of the fraction, a lot of times it'll get rid of your anxiety. Because this one is pretty much straightforward. What would you do next? Multiply to remove parentheses. 8 times y is 8y. 8 times 4 is 32. Negative times positive is negative. 7 times x is 7x. Negative times positive is negative. 7 times 3 is 21. Simplify. Always, whenever you get rid of parentheses, the first step you want to do is combine like terms if possible. If nothing is like terms, then solve for y. We want to get y by itself because that's the form we're looking for. So we have to get rid of 32. We add 32 to both sides. 32 is bigger than 21, so the answer is positive. 32 minus 21 is 11. Get rid of the 8. Divide each term by 8. And there's your equation of the line. Pretty easy. Let's put all the numbers being fractions now. Put in the slope-intercept form. Here are the steps. What's the LCD in this case? What's the smallest number that 3 and 5 both fit into? 15. If you don't see it automatically, just multiply them together. Because our objective is whatever this number is here, when we multiply them to each term, we want to make sure that they cancel. We multiply the LCD. Now we reduce, we cancel. The 3 goes into 15 5 times. The 5 goes into 15 3 times. 3 goes into 15 5 times. Because again, if we multiply 3 times 5, we know that they're going to cancel. So now we multiply to get rid of the parentheses. Well, this is what we have. We have 1y. This is what we have right now. Multiply to get rid of the parentheses. 5 times y is 5y. Negative times positive is negative. 3 times 2 is 6. 5 times 2 is 10. We still have a parenthesis, so we have to multiply again. Ten times x is 10x. Positive and negative is negative. 10 times 6 over 5. Five goes into 10 twice. So we have 2 times 6. Oop, 10x. That's why. Because the only problem you should have had so far is the very first step when we found the LCD and multiplied. That's the only hard part about this whole thing, I think. So now we have 5y minus 6 equals 10x minus 12. We want to solve for y, so we have to get rid of the 6 first. Subtract or add 6 to both sides. Negative 12 is bigger, so it's negative 6 minus 12 minus 6 is 6, and divide by 5. Y equals 5 goes into 10 twice. And there's our answer. There's the answer in slope-intercept form. It just takes practice, but the steps are there. When we talk about solving or solutions to equations, a solution to an equation that has two variables is a point. You need to have an x value, you have to have a y value. And that point has to be true. Is that a solution to that equation? 4x minus 5y equals 20. Is negative 5, 4 a solution to that equation? Plug and play. So this is my x value. This is my y. In place of x, I put a negative 5. In place of the y, I put a 4. Positive times negative is negative. 4 times 5 is 20. Negative times positive is negative. 5 times 4 is 20. They're both negative, so the answer is negative. 20 plus 20 is 40. Is it true? No. Not a solution. Find me a solution to that one. What's the easiest way we can find a solution? Start with the intercepts. How do we find the intercepts? How do I find the x-intercept? What are my steps? Set y equal to 0, because I'm looking for the x values only. I don't want a y. Then solve for x. For the y-intercept, since I want y, I get rid of the x. Set x equal to 0. And solve for y. That's the easiest way to do them. So for the x-intercept, I set y equal to 0. So -4 equals 3x. Divide both sides by 3, because we want x by itself. So one solution is that. The second one we can find the word solution has many definitions. It could be the same as the x-intercept. The root of an equation. We'll get to those later in this course. There are two more: x-intercept, root, factor, and something. I forgot another one, but they all mean the same thing. They're all synonymous. So if you're asked to find a solution of the equation, we're going to restrict ourselves to the x-intercept. The first question I asked, is this point a solution to that? In other words, does it complete the sentence? Make it true both sides. That's different than if I ask you to find a solution. When you're asked to find a solution, you set x equal to 0 and solve for the value. Look for the x-intercept. What if we had two equations? If we had two equations, what would a solution be there? Remember, equations are the same things in this case, same thing as lines. If we had two lines, what would be a solution? Where the two lines intersect or they cross. So if we have two lines, there could be four possibilities. If we have two lines, there could be four possibilities. If it looks like this, we call these lines parallel. And in shortcut notation, we simply use the two slash marks. This one has no solutions because they don't cross. So this is line 1 and this is line 2. Another one, this could be line 1 and this could be line 2. They could be the same line. How many solutions does this one have? Very good. Infinite solutions. Because every point is a solution because they overlap each other. But they look the same. How would I tell those two apart if I look at the equations? What's different between these two? Well, yeah, because this one has no solutions, this one has infinite solutions. Solutions are the answers, yeah. But what looking at the equation, just the equations themselves, what do we notice that are different about them? What's the same with them? Remember, we had an XY graph. We have an XY graph. So what do these two have in common? What do they have different? The slope of line 1 is the same as slope of line 2. They're parallel, they never cross. But in the same line, aren't their inner slopes the same? Yeah, they have to be. So that still doesn't tell us how they're different. How are they different? What do those represent? The y-intercepts. If the lines are parallel, the slopes are the same, but the y-intercepts are different. If the slopes are parallel, if the lines are parallel, that means the slopes are the same, but they cross the y-axis in two different places. If it's the same line, then both the slope and the y-intercept have to be the same. That's how you tell these two apart. It's either no or infinity solutions. On these two, we can't use the y-intercept as a condition because they can cross at the y-intercept. So the y-intercept is not in contention here. This little box here means that's a 90-degree angle. We call these two lines perpendicular or orthogonal or normal. That means there's different ways of saying it in mathematics. The symbol for this one is an upside down T. If two lines are perpendicular, We know they have one solution. And if any other lines, anything else, it has one solution also. But again, what's the difference between the two? We're just looking at, if we just look at the equations, we know if the slopes are the same, it's either one of these two. If the slopes are different, it's got to be one of these two. In perpendicular, the slope of line 1 is negative, opposite signs, and they're flips of each other. If they're perpendicular, the slopes are the opposite signs and they're flips of each other. They're reciprocals of each other. And the last one is just that the slopes are just different. That's all we know. How about these two lines? Which one of the four conditions does these two satisfy? They're what? They're parallel. What's the slope of this one? Three over two. Remember, these are both in slope intercept form. Whatever's in front of the x is your slope. The slope of this one is also 3 over 2. If the slopes are the same, they have to be one of these two. So we look at the y-intercepts. The y-intercept of this one is -5. The y-intercept of this one is +5. So they're same slope, different y-intercepts, has to be parallel. I want you to tell me the slopes that are parallel and the slopes that are perpendicular. If I gave you the slope of 4, what's the slope parallel and what's the slope perpendicular? Very good. Because this is, all slopes are always fractions. So the slope parallel has to be the same slope. Perpendicular, it's opposite signs and they're flips of each other. So the next one, slope is -2 over 5. What is it parallel? Go ahead. Yeah, slope, parallel slopes are the same. So whatever this is, it's here. What is perpendicular? Change sign and flip. So what's it going to be? 5 over 2. Since that's negative, this has to be positive, right? Now, the last two, before I dismiss you guys, is going to take some thinking. What's parallel? It's a 0 slope. It can be 0. The parallel slopes are identical. So this is 0/1. What is it perpendicular? 1/0. You cannot divide by 0, so it's undefined. So if I give you the slope is undefined, the parallel slope is also undefined. What's the perpendicular slope? Undefined looks like what? 1/0. What is perpendicular to 1/0? Which is 0. Now, why is 1/0 undefined and 0/1 0? How many times does 1 go into 0? You can't. 0 times. So that's why it's 0. How many times can nothing go inside 1? How many ways can I give you nothing? If I promise to give you nothing every day, how many days can I do that? Forever. This is equal to infinity because 0 goes into 1 infinite number of times. So that's the difference. That's why it's undefined, because it doesn't exist. It's not a solid number. All right, so we'll look at some of these equations next time. I'll give you two lines, and I'll ask you to find whether they're parallel, perpendicular, or what. And then we're going to find equations of lines. I'm going to give you one line and 1 point from the other line. I'll ask you to find the equation of that one. And then we're going to talk about inequalities. Okay, everybody, that's it for today. Go enjoy the sunshine, sleet, snow, whatever's going to happen.